Alright, this video is on significant figures. These happen to be the rules out of your textbooks for counting significant figures. We will go over them one by one. So number one, non-zero integers. So non-zero integers always count as significant figures. Okay, you may hear me say the term significant digits. Okay, significant digits, significant figures, or SigFigs, same thing. So, for example, the number 1,457 has 4 non-zero integers, which means all of them count as significant figures. So, if I was to have 1, 3, so say 13, that would be considered 2 significant figures. If I had 4,651, there's 4 significant figures, meaning every single one of them, because they're non-zero integers, they are significant figures. Another one would be 2.63. Okay, so I mean even numbers that are parts of numbers values that are less than 1, the decimal points, those still, because they're non-zero integers, they would still count as significant figures. So take a look at the next one. So zeros. Now this is where it can be a little tricky, but it's not that difficult. Okay, there are 3 classes of zeros. Okay, the first one, leading zeros. Okay, leading zeros are zeros that precede all of the non-zero digits. They are never to be counted as significant figures. For example, the number 0.0025, the 3 zeros, this 0 right here, this 0 right here, and this 0 right here, they simply indicate the position of the decimal point. They do not have any significance as far as for SigFigs when we do calculations. Okay, the number has only 2 significant figures. That would be 2 and 5. Okay, so let's go ahead and take a look at this. Okay, 0.03, that's not a 3, 2, 3. In this case, these 2 zeros, oops, let's go back to this. 0.023, this number right here and this number right here, these zeros, they are not significant. These are the only 2 significant digits, or the significant figures for this number. Okay, a different number. 3.450. Okay. Now this 0 is actually going to be a little different, so we'll get rid of that number. We'll go back to that. That's actually rule 3. Okay, but all placeholders, such as that. Okay, even though that number has 1, 2, 3, 4, 5, 6 different numbers there, this is the only significant figure. All of these are not SigFigs. The next is captive zeros. Captive zeros are zeros that fall between non-zero digits. They are always counted as significant figures. For example, 1.008 has 4 significant figures, meaning all 4 of the numbers are significant. Okay, so 3.201. Okay, because this 0 is captive or in between 2 non-zero integers, it will also count as a significant figure. Okay, 20003.001. Okay, because non-zero integer, all 4 of those significant. Non-zero, these 4 are also significant. So you'd actually have 8 SigFigs in this number right here. Alright? Next, trailing zeros. Now, zeros that are at the right end of the number, okay, they only have significance when they're written with a decimal place. Okay, so take a look. The number 100 can be written as 100, meaning 100. That one only has 1 significant figure, but if we actually write down 100 decimal, then it would have 3. I know that sounds a little tricky, but we'll explain it here in a second. Alright, So we go 1, 2, so 1200. Okay, and then we have 1200. Now, because there is a decimal on the second one, we would say that there are 4 significant digits. When there's no decimal, then you'd only have 2 significant digits. Now, the reason why being this decimal place indicates a certain level of accuracy to that point. Okay, here this is because there's no decimal there, it's kind of an obscure number. It's like it was an estimated number. Think of without the decimal, they are considering it to be around 1200. But with the decimal, it's exactly 1200. Okay, so the decimal indicates that there's a certain level of accuracy in the value versus without the decimal, it's almost like it's an estimate. So remember, with the decimal, all the numbers, even the zeros, are going to be SigFigs. But without it, these are not SigFigs. Okay. Next rule. Exact numbers. Often calculations involve numbers that were not obtained using measuring devices but are determined by counting. Okay, so for example, if you not using a ruler or graduated cylinder or a triple mean balance, the measuring devices, if you were able to just do it by counting, for example, I have 4 pins in front of me. Those 4 pins, those are exact numbers, which means they could have what we call an unlimited amount of significant figures. And because and I know that sounds a little odd, but the main rule, or main part of the rule that you need to worry about is that whenever there is an exact number, okay, whether that be exact because I counted them or I have exactly a certain amount in an equivalence. For example, there's 12 inches in a foot. Both of those cases, whether I counted it or I know that, for example, there's 2.54 centimeters in an inch and there's 12 inches in a foot. Okay, those conversions, those direct statements of relation, okay, they do not limit them. Okay, so they do not limit the significant figures when using the calculation. So if I end up having to use an exact number, like 3 apples, 8 molecules, 10 experiments, or I have, I need to do a conversion in my problem first, and I need to get to 1 inch and I need to get into centimeters, and that would be 2.54 centimeters, because they are they're equivalency statements. Okay, they would not have any bearing on the significant figures when you do a calculation. And speaking of calculation, that's what we're going to do next. Okay, so those calculations that I was referring to, the main calculations that we're going to be doing in this class is going to be dealing with multiplication and division, especially when we do dimensional analysis. So there are different rules when it comes to addition and subtraction, but the rules that I mainly want you to pay attention to are going to be SigFigs of multiplication and division calculations. So let's go ahead and take a look at the first one. So for multiplication or division, the number of SigFigs in the same as the measurement with the smallest number of SigFigs. Okay. Another way we call it the limiting number of SigFigs. So for example, here I have 1, 2, 3 SigFigs, but I multiplied it by a number of 1, 2 SigFigs. And my calculation, when I actually put it in the calculator, I'm actually going to get 4 SigFigs. But because 2 is the limiting number of SigFigs, how I round it needs to have 2 significant figures. Okay? So, like I said, it's right here out of your book. It says because 1.4, right here, has only 2 significant figures, it limits the result of the 2 significant figures. Thus, the product is correctly written as 6.4, which has 2 significant figures. Okay? So, let's go ahead and take a look at another example. Move the board over a little bit. So, here's the other example. Okay, the division of 8.315 divided by 298. Okay, how many significant figures should there be in the answer? So if we take a look, this sig fig, or sorry, there are 4 sig figs up here, and there are 3 sig figs down here. Well, remember, we look at the smallest number. That's going to limit the number of sig figs in our answer. So because 3 is smaller than 4, we know when we round our answer, we need to make sure that it is to 3 sig figs. So because, like I said, 8.315 has 4 sig figs, and the number 298 with 3 sig figs limits the results. The calculation is correctly represented below. Okay, so 4 sig figs here, 3 sig figs there. The answer comes out to be with how many sig figs? Do we know how many sig figs are right here? Okay, if you counted 6, you're correct. Because 1, 2, 3, 4, 5, 6. This is a placeholder. Okay, that is not a sig fig. So there are 6 sig figs here, but because 3 is going to limit, my answer is going to be 279. Now, they wrote theirs in scientific notation, which I have not showed you how to do yet, okay, which we'll probably do next week at the beginning. But if I was to write this number with 3 sig figs, it would be 0.0279, and then whatever my unit happens to be. Obviously, right now, the unit is being ignored because we're mainly focusing on the values and what are the appropriate values for an answer. All right, so let's do a couple problems. Let's go ahead and I'll go ahead and write these out. Okay, so I wrote a couple problems out. Let's go ahead and do them. Okay, I'm bringing up the calculator so you guys know what I am. That's not what I wanted to do. Let's erase that. I'm gonna lose my number a little bit. Okay, so bringing my calculator so you guys know what's happening. So first thing we should do is identify sig figs. Okay, so in this calculation, I have 1, 2, 3, 4 sig figs. Over here I have 1, 2, 3 sig figs. So my limiting, this is going to be my limiting number, 3 sig figs, right there. Okay, calculator disappeared. Bring it back over. Okay, so we have 362.1 times 0.0346. My answer is, let's write that out, 12. Of course, I lost it. Let's put it back up. Okay. Okay. 12.52. I think 6 was also there. All right. So looking at that, I obviously looking with 3 sig figs, I don't really need to know about the this number right here, but this number right here becomes important because it's going to determine how I round the nearest sig fig. And because number 2 is lower than 5, then I would not round 5 up to 6. So my final answer is going to be 12.5. All right. Now, do another one. So 263.1 divided by 1.0031. Identify sig figs. Here I have how many? 1, 2, 3, 4. So I have 4 here. 1, 2, 3, 4, 5. I have 5 here. The reason why these 2 zeros right here are sig figs is because 3 and 1 are non-zero integers, which means these 2 numbers are, or these 2 zeros are significant. And we'll go ahead and just put a little nose on that guy right there since he's happy. Okay, so real quick, I'll calculate that. My final answer is going to end up being 262.2869. Okay, well, I am limiting to, so sorry, I forgot to mention, that's 5. I'm limited to 4 sig figs. So this is a sig fig 1, 2, 3, 4. Now, this number right here is just as important as this number right here, okay? This is the number to be used to round to my appropriate sig fig. Since 8 is larger than 5, my final answer should be 262.3 and then whatever my unit happens to be. Okay, so there's a couple examples. If you guys have any questions in class, please make sure you ask.